Okay, so in this situation here, you need to appreciate that you've got this particle P here, right? And it's held in balance, in equilibrium, by these two strings. That's attached to the wall, so there's a tension there, isn't there? Okay, and then there's a string here, and an incline, which is attached to A. So these two strings are holding this particle P in a balance. And remember, particle P has got some sort of weight, doesn't it? Now, I've drawn it out here on a force diagram to show exactly what's going on, all right? So we can see here, we've got the tension then in that string, which they say is 30 newtons, doesn't it, in the question. So the tension here, pulling this particle P, and then there's a tension here at an angle alpha, which we need to work out, okay? And it's keeping this particle P of weight 4g in a balance, all right? So what we've got in a situation like that, we need to then look at the forces in the horizontal and a sort of vertical direction in this case, yeah, because it is in the vertical plane, with the weight acting as the downward force, okay? So we need to appreciate them. We've got 30 newtons going this side, okay? Now in terms of our forces, if you think about it, if we call this tension in AP, right? So going along here, we don't know what this tension is, so we can call it T AP if you want, or T1, or we just call it T because we know what that tension is there, 30 newtons. So if we call the tension in this T, right? And of course, with the angle alpha there, when you resolve it along here, it'll be T cos alpha, and then vertically then along that direction it'll be T sine alpha, okay? And then we've got the 4g then going down. Now they're in equilibrium, okay? So quite simply then we say, you know, that the forces up will equal the forces down, and the forces to the right will equal to the forces to the left, okay? So we say, look, in equilibrium, so therefore, okay, resolving vertically, T sine alpha will equal 4g, and resolving horizontally, T cos alpha will equal 30. Now when you get this and they want you to work out the angle alpha, it'd be best if you do as I did here. So you're having the T sine alpha on the left hand side equals 4g, and then when you do resolve horizontally, put the T cos alpha first equals 30. So you see these are nicely lined up then, alright? And what you can do, right, to work out alpha, okay, and T, well first of all we work out alpha, what you can do is you can divide, can't you? You can do 1 divide by 2. Okay, that's the technique you use here. Because if you do 1 divided by 2, okay, you'll notice I've got that, yeah? T sine alpha over T cos alpha. And on the other side then, I'll have 4g divided by 30, okay? But what's good is the t's cancel, and I'm left with, because t divided by t, yeah, is 1, I'm left with sine alpha over cos alpha, which of course is tan alpha. Sine over cos is tan, and I've got this, 4g, 4 times 9.8 over 30. So then to get alpha, I just take the tan, you know, do the tan inverse, yeah? So I get tan to the minus 1, 4 times 9.8, divided by 30, and it comes out to be 52.6 degrees, okay? 1 decimal place. So then, quite simply then, to get the tension, you just got to sub it into one of these, okay? So we can say then, look, sub into, so then T cos of 52.6 equals 30. So then to get T, of course, I need to divide, and we get that. So what I'll do on my calculator, if I do 30 divided by cos ants, I'm going to get an accurate answer then, and that comes out to be 49.4 newtons.